In this video, we will explore the relationship between length, area, and volume. And let's just jump straight to the bottom line. Okay, when it comes to length, area, and volume, if the length is x, just keeping it general for now, then the area will be x squared, and the volume will be x cubed. So just a quick example so you know what I'm talking about. If a length is, let's say, 2, all right, like if this little line right here has length 2, then the area that I would get if I made a square out of that would be 4. And the volume I would get if I made a cube out of that would be 8. All right, notice that I'm not getting the 8 from the 4. Everything is coming from the 2. All right, if I take this 2 and I square it, then that's giving me area. If I take this 2 and I cube it, all right, so I'm doing x squared. If I take this 2 and I do 2 to the third power, then that's where the 8 is coming from. Notice that it goes the other way too. If I gave you a square and I told you that the area was 9, and then I could ask you for the length and the volume. Well, if the area is 9, start by telling me what the length must have been. Okay, what squared will give you 9? So technically, if you wanted to find this, you would do the square root of 9. And that's going to turn out to be 3. Maybe I'll just keep this yellow. Okay, and then once I know that the length is 3, then I can use that length to find the volume. Because the volume is the length cubed. So 3 to the third power turns out to be 27. So I started with the area. I could work my way backwards to get the length, and then I could get the volume. One more real quick. If I told you that the volume was 64 and I wanted the length and the area. Again, first, you always start with the length because that's what everything, all of my little formulas are based on the length. So this is x cubed. If I want to find x, I would have to do the cube root of this. So if I want to find the length, I would have to do the cube root of 64. Now I could do this on my calculator if I needed to. The way you do a cube root on your calculators, you type in the 3, and then I'll hit second, and I'm going for this little x root. So that makes it the cube root of 64, and that is 4. Okay, so that tells me that the length would be 4. And then, if I want the area, then I would square that. So I would then do 4 squared, and that's going to give me 16. All right, so I started with the volume. I could get the length and the area. So if you give me any one of these, I can find the other 2. All right, so for example, problem number 1. 2 polygons are similar, and the ratio of their areas is 64 to 81. What is the ratio of their perimeters? So look, here's the key. They're giving us areas, and they're asking us for perimeters, but is perimeter a length, an area, or a volume? Hopefully you can understand that perimeter is a length. Okay, so basically they're giving us area and they're asking us for length. Okay, so they told us that the area, well, the ratio of areas is 64 to 81. Okay, so that means we have 64 to 81. So we need to find the ratio of lengths. So if they give us an area and you want to find the length, you're going to have to do the square root. So I'm going to need to do the square root of 64, and I'm going to need to do the square root of 81. Okay, that's how you go from area back to a length. So the square root of 64 is 8, and the square root of 81 is 9. So the lengths must have ratio 8 to 9. Two rectangular prisms, boxes, are similar. The ratio of their side lengths is 2 to 3. Okay, so we have the lengths, or perimeters, have ratio 2 to 3. This is like x. The ratio of areas, we'll have to do x squared, and the ratio of volumes, we will have to do x to the third power. So if we square these, we're going to get 4 to 9. Now for the volumes, I'm still going all the way back to these. All right, but I have to cube them. So I need to take 2 to 3, and I need to cube each one of those. So 2 to the third power is 8, and 3 to the third power is 27. Okay, if you don't know those numbers in your head, remember we can do exponents like this: 2 to the third power and 3 to the third power. If the smaller box has a surface area of 864 square centimeters, what is the surface area of the larger box? Okay, well, we have a smaller box and we have a larger box. So, you know how we always go new over old equals new over old? We're going to do the same thing, but instead of calling it new and old, we might as well call it small and large. So I'm going to say small over large is equal to small over large. Okay, so the smaller box has a surface area of 864. All right, and we're looking for the surface area of the larger box. So I'm just going to call that X because we don't know. Now, we need another small over large, and for that we're going to use the ratio of areas. All right, it's basically the scale factor, but we'll just make sure to do it in the order small over large because that's what we decided on. So we will do 4 over 9. Okay, how did I know to pick this one and not the 8 to 27 or 2 to 3? Because we are talking about area. So I'm picking the area scale factor. So now it's just a matter of solving this equation. All right, so I'm going to cross multiply, and that's going to give me 4x is equal to whatever 9 times 864 is. Okay, so that's 7,776. And then, of course, I will divide both sides by 4. And that turns out to be 1,944. Okay, and these are square centimeters, which you can just write like that. So that is the answer for number 2, part B. Now, if the larger box has a volume of 1,080 cubic centimeters, what's the volume of the smaller box? Okay, I think we will once again do small over large equals small over large. So what is the volume of the smaller box? We don't know. That's what we're looking for. So we just call that x. But then the volume of the larger box is going to be 1080. So small over large equals small over large. Now, over here we'll put the scale factor for volume. And when we write it, we'll just be careful to do small over large. So we will do 8 over 27. And then you cross multiply. So that's going to give us 27x is equal to, and whatever 8 times 1080 is, that's 8,640. Okay, then I need to divide both sides by 27. $320. All right, 320 cubic centimeters. All right. Always go back and check in terms of common sense. Does it make sense? In other words, if you have a small and then a large, excuse me, does your answer turn out to be small and large as it should be? So for example, the smaller box had a surface area of 864. The larger box had a surface area of 1,944. That makes sense because this is smaller, this is larger. If you wind up getting a smaller number, that's a hint that you did something wrong. And here, we're supposed to be, now we're supposed to find the volume of the smaller box. So this is larger, this number is smaller, so it does make sense. Triangle ABC is dilated by a scale factor of 4/5 to create triangle A prime, B prime, C prime. Fill in each box. So that tells us the ratio of lengths or perimeters, all right? It's going to be the scale factor. If I want the ratio of areas, I need to square these. So that's going to be 16 to 25, all right? I just did 4 squared and 5 squared. Now, if a side is 20 inches long, if side AB is 20 inches long, how long is side A prime, B prime? Okay. So, I think I will stick with small over large equals small over large. We just have to be careful to identify which triangle is small and which triangle is large. So look at the scale factor. See how this scale factor is less than 1? That tells us that this shape is shrinking. So the new triangle is going to be the smaller one. And the original triangle is going to be relatively large. So AB is from the original triangle, so this 20 is a large, and this A prime, B prime that we're looking for is going to be a small. So when I set up my proportion, I'm going to do small over large. So I'm going to put X to represent the length of side A prime, B prime. That's going to be a small. And I'll put it over 20, which is large. And then, am I going to use 4 to 5, or will I use 16 to 25? Okay, we're talking about sides. These are lengths, not areas. So I'm going to do 4 over 5. Okay, small over large. And then you just cross multiply. So that is going to give us 5x is equal to 80. And then I have to divide both sides by 5. Which turns out to be 16. Okay, did they give us units? Inches. So let's see, 16 inches. Okay, if the perimeter of ABC is 100, what's the perimeter of A prime, B prime, C prime? All right, perimeter is still length. So notice when it comes time for the scale factor, we will still be doing 4 to 5. So, like we already decided, the original triangle is the large, and the A prime, B prime, C prime is the small, and that's what we're looking for. So, I'm doing small over large. So that's going to be x over 100, okay, because that's small over the large, is equal to 4 over 5. So it's really exactly like the last problem was. So when we do our cross multiplication, I'm going to get 5x is equal to 400. And if I divide both sides by 5, then x is going to equal 80. Okay, this is 80 inches. Now the area of triangle ABC is 400 square inches. What is the area of A prime, B prime, C prime? And remember, the original triangle we decided was the large one. Okay, and the A prime, B prime, C prime, that is the small. Okay, don't forget about that. So once again, I'm going to do small over large is equal to small over large. Okay, we're looking for the small one, so I'm just going to call that x. So we'll have x over 400. But be careful, these are now areas that we're talking about. So because we're talking about areas, we're going to use the area scale factor. So that's going to be 16 over 25. And then you just have to cross multiply. So obviously x times 25, that's 25x. 400 times 16, that's 6,400. So there you go. Then you have to divide both sides by 25. So divided by 25, 256. Okay, we're talking about area, so this will be square inches, which you write like this. In problem number 4, we are given the perimeter of parallelogram A is 28, and the perimeter of parallelogram B is 56. So that means the ratio of these perimeters is 28 to 56. Now I would like to reduce this, just treat it as a fraction. Another way of writing 28 to 56 is 28 over 56. Okay, so 28 over 56, that's 1/2. All right, in other words, we're talking about a ratio of 1 to 2. So this is what we should really use. So if the ratio of the lengths is 1 to 2, the ratio of the areas is going to be 1 to 4. Because to get the areas, you have to square these. So we're doing 1 squared to 2 squared. So that's 1 to 4. All right, now find the value of x. Well, obviously it's going to be 8, all right, because a ratio of 1 to 2, that means we're doubling. So that means this must have been 8. But let's go through the motions. All right, let's do small over large is equal to small over large. Okay, so the small length here is x, and the large length is 16. Okay, and then so using the ratio of perimeters in the order of small over large, that would be 1 over 2. So if you cross multiply, that's going to give you 2x is equal to 16. And then if you divide both sides by 2, that's going to give you x is equal to 8. Now, the area of the parallelogram B is 144. Okay, so we're talking area is 144 square units. So obviously that's the bigger area. So what's the area of parallelogram A? So understand that we're talking about the small area now. Okay, so once again, I'm going to do small over large is equal to small over large. All right, so they gave us the large area, and we're looking for the small area. So I'm going to do x over 144. All right, small over large. Okay, and now I need the scale factor. But we are doing areas, so I'm going to use the area scale factor, so which is 1 to 4. And if I cross multiply, I'm going to get 4x is equal to 144. And then I will divide both sides by 4. Okay, so 144 divided by 4. That is 36. Okay, so I'm going to say 36 units squared. Because we're talking about area. So this could get confusing because I'm using x, but they already said, you know, x is this length, so maybe I shouldn't have used x. There, I used y, so it wouldn't get confused with x. For number 5, we were given two areas. The area of shape A is 1,278. So obviously that is the large area. And the area of shape B is 142 square units. Obviously that is the small area. Okay? So fine. The ratio of areas is 142 to 1,278. But we need to reduce this. So I'm going to do 142 over 1,278, so I can see what we're dealing with. And I get 1/9. So the ratio of areas is really 1 to 9. Okay, and this is the version that we are really going to use. So if I want to find the ratio of lengths or perimeters, I need to do the square root of these. All right, so I want to find the ratio of lengths. It's going to be the square root of 1 to the square root of 9 because I'm working backwards. All right, you square the lengths to get the areas, and then you take the square root of the areas to get the lengths. So this will be 1 to 3. Okay, so now we should be able to find anything they asked us to find. Find the value of x. Okay, so I am going to do this in the form small over large is equal to small over large. So x is a small length, so I'm going to put that in the top. 36 is the corresponding large length. Okay, so now I need a scale factor. Will I use the length scale factors or will I use the area scale factor? Well, 36 is a length, not an area. So is x. So we better use the length scale factor, 1 to 3. If you cross multiply, you're going to get 3x is equal to 36. Then if you divide both sides by 3, you're going to get x is equal to 12. Okay, did they give us units? They're just saying units. I'll just say 12 units. Okay. If the perimeter of shape A is 180, all right, remember that shape A is the large shape. What is the perimeter of shape B? Remember that shape B is the small one. Okay, so if I continue writing my equation in the form small over large equals small over large, we're looking for shape B. So I started to say that's x, but we already had a variable for that. So I'm going to call it y. Okay, let's let this be y. The perimeter of shape B, that's going to be y. So we will have y over 180. Okay, that's small over large. And for the other fraction, we need the scale factor. Obviously, since we're talking about perimeter, we will use the length and perimeter scale factor of 1 to 3. Cross multiply, and you end up with 3y is equal to 180. Divide both sides by 3. And you end up with y is equal to 60. We're talking about perimeter, so it'll simply be 60 units. All right, two triangles are similar. The smaller triangle has side lengths 4, 5, and 6. Okay, let's go ahead and draw that. Okay, so here comes the smaller triangle. Boom. Oh, you know what? I guess I messed up. Let me do that again. So smaller triangle. Boom. 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 Okay, that's a smaller triangle. And then there's a larger triangle, so I'm going to draw that. Boom. 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 Okay, great. The smaller triangle has side length 4, 5, 6. Okay, so let's see. 4, 5, 6. Now the longest side of the larger triangle is 24. So that will correspond to the longest side of the smaller triangle. So I'm going to put it in the same position, put the 24 right here. So we can easily solve this by setting up a proportion. It's going to be in the form small over large is equal to small over large. So for the first fraction, we can just use one pair of values. And then for the second fraction, we'll go ahead and use perimeter. Okay, let's see how it goes. So we can just use the 6 and the 24 for the first fraction. So 6 over 24, small over large. Now, let's talk perimeter. So the perimeter of the small triangle, let's see, that's 10, 15. And we're supposed to find the perimeter of the large triangle, so that's the thing I will call, well, you know what, let's call it P for perimeter. Now, I like to reduce these things, so this would reduce down to 1 over 4. And then when you cross multiply, you simply get P, because 1 times P is P, and 4 times 15 is 60. Okay, and the units are centimeters, so there you go, centimeters. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.